Sine and cosine, when we get ready for trig identities, we gotta remember we're to graph. When we graph the sine of theta, this is what comes up. And it's an oscillating pattern. Okay? And it oscillates up and down and up and down and up and down. It's very constant. Now certain things happen to sine and cosine. When we change things on the inside or when we change things on the outside, okay? But right now what we want to learn is the basic pattern of what sine looks like and what cosine looks like. And if you look at them, remember when we were doing cosine of one angle seemed to be equal to the sine of the opposite angle, right? Did you notice that pattern in the triangles? Hopefully you did. And the reason is because they're opposites of each other. I mean, let's think of it. Let's see what's going on here. At 0, sine is 0. But as we get to pi over 2, right? Or halfway to pi, we find that the altitude, this is the altitude, at pi over 2 is equal to 1. Excuse me. It's equal to 1. Okay? And as we get over to pi over 3, or I'm sorry, 2 pi over 3, okay? Oh, no. Gosh, what is wrong with you? 3 pi over 2, because it's 3 halves, duh. 3 pi over 2. As we get to 3 pi over 2, this altitude is still 1, right? It has a distance of -1, comes down to -1, but the altitude is still 1. And altitude's the absolute value of the height of. It's just talking about the absolute value of the height of the curve. Okay? And it just continues off that way. Okay? Now, cosine is just sine shifted. Right here. Right? This is just right here. That's it. So it's the whole thing shifted over. And so at cosine, you have the altitude at 1. At cosine 0, the altitude of 1, right? And then as you come over to pi over 2, cosine is 0, right? And then when you get to pi, now you're back to the 1. The altitude is 1. And then you get 3 pi over 2, we're back to 0, and then we come back to 1 at 2 pi. Okay? And that's cosine, that's the graphs of cosine and sine.